In this video, we are going to solve problem C, a good problem from latest Codeforces round 1035. In this problem, we are given N, L, R, and K, and we have to find the lexicographically smallest array of length n. Here I will be between 1 and n, and the elements of the array will be in the range of L to R. And in the array, the AND operation of all the elements will be equal to the XOR of all the elements. And if we can create such array, then we will print the kth element of the array. And if no such array exists, we will just print -1. So at first, let's see what do they mean by lexicographically small. So between two array 1 and array 2, we will see that the moment where the element of the array differ. We see the first two elements of both of this array are equal. In the third element, 5 is smaller than 6. So here the elements are not equal. So we don't need to check for this element. There can be more element here, but we don't need to check because we find that in this index 5 is smaller than 6. So we will say array 1 is smaller than array 2. Then I want to show some basic concept of XOR and AND that we will need in this problem. If we XOR two same number, the result will be 0. For example, we'll take 5. The binary representation of 5 is 101. So what will be the XOR of 5 and 5? So 5 XOR 5 will be 0. Here the number of 1 is 2, and here it says that if there are odd number of 1, the XOR will be 1. So here there is even number of 1, so we'll print 0. And here there is no 1, so we'll print again 0. And this is same as the first, so again we'll print 0. And end of two same number will be the number itself. Again we'll show the example for 5. For AND, if all the bits are 1, then only the AND will be 1. Here all the elements are 1. Here also all the elements are 1, so we'll print 1. There is no 1, so we'll print 0. To solve this problem, at first let's see what if n is odd. Here I will show it for n equal to 5, and it will be same for all odd number. Here again we will see example of 5101. So here in this bit we can see the number of 1 is 5. So as it's a odd number, we'll print 1. And here we see there is no 1, so we'll print 0. And here this is same as the first one, we'll print 1 because the number of 1 is odd. And if we see the end, Here the all the bits are 1. Here also all the bits are 1. So here we will print 1. There is no 1, so we'll print 0, and again we'll print 1. So we can see if n equal n is odd, the XOR and AND of the array is same. So in this case we can choose any number and create, and all the element of the array will be same. So as we can choose any number from the range L to R, we'll take L because the question says that we have to output the lexicographically smallest array. So L is the smallest in this range, so we'll print L, and it's only for n equal to n is odd. But what if n is even? At first, for the first n minus 2 element, we'll print L, and for the last two elements, we'll print the smallest number which is power of 2, and the number should be in the range of L to R. So let's see for n equal to 6. Here for the first, let's say that here the range is 5 to 10, and in this range we have to, for the first n minus 2 element we'll print L. Here I print 5, and for the last two element we'll print the smallest number which is power of 2. So, and it have to be greater than L. So here I will, the number which is power of 2 is 8. 8 is power of 2 to the power 3. So let's write 8. The binary representation of 8 is 1 0 0 0. Let's copy it. So what will be the XOR and AND of all this number? So at first let's see what will be the XOR of all this. So here we have even number of 1 here. So for this we'll print 0, because if the number of 1 is even, we'll print 0, and if odd, then we'll print 1. So for this there is no 1, so we'll print again 0, and again for this there is even number of 1, and here also there is even number of 1, so we'll print 0 0. So XOR of all of this is 0, and the end of all, so as the XOR of all these are 0, the end of all of these numbers also should be 0. So let's see what is the end of all this number. So the end will be 1 if all the bits are 1. So in this case we can see there is no point where all the bits are 1. So in all this we didn't find any point where all the bits are 1. So the end of all this number will be also 0. So that is how we can say if we choose element like this, for the first element we'll print L, and for the last two element we'll print the smallest number, which is power of 2. We can construct an array which will satisfy our this condition. This, and if we don't find for a number in L to R which is power of 2, we'll print -1. If I want to show you the code, at first here I have to give an additional condition for n equal to 2, because if n equal to 2 there is no way we can construct array. Here we write this condition for n is odd, and you can ignore this, and here I calculate if there is any number in the range of L to R. If there is no element in this range which is power of 2, then we'll print -1. And if there exists such element for the first n minus 2 element, we'll print L, and for the last two element we'll print X. So this is the code for it.